All right, class, here we go. Today's the 24th. Make sure you have all the stuff. Page 11, get there. Remember, this is a video. Just pause it whenever you need. We're talking about horizontal translations today. Horizontal is this, okay? That's going left and right. And for those that need it, this is left and this is right. Okay. Now we're gonna find the vertex, domain, and range of each of these parabolas. So the vertex, which is this point right here, of course, is 1, 4. Awesome. The domain is always, for parabolas anyway, gonna be all real numbers. And the range, remember, we have to look at this like line. We can just draw this line in if we want, where the vertex is, and see, oh, it exists below this line, right? So that's y, it's always y, is less than or equal to, and then the y value of the vertex, which is 4. All right, and there's one more thing, of course. Like from the parent function, like the parent function is this f of x equals x squared, right? It's got a vertex right there. From that parent function, we can see this function moved to the right 1, like it didn't get to that x value of 1. So it moved to the right 1. All right. So that's something we'll learn about, just introducing the idea right now. All right, next one. Okay, same thing. Here's a parabola, finding the vertex. The vertex is right here. That's at the point 2, -9. Feel free to count it if you want to. It's 2, -9. The domain is always the same, all real numbers. And the range, again, draw in a line or imagine a line right across the vertex like that. And it only exists above, right? So it's y is greater than or equal to the -9 that's in our vertex. And again, same thing. If we compare this function we're given to the parent function, okay, we just look at their vertexes, and we can see that this vertex that we got, it's at 2, right? The x value only is what I'm looking at because we're just moving horizontally. So this thing moved to the right 2 from the parent function. So we'll go through more stuff like that later. All right, here, again, we're moving these like I keep saying. Okay, we're gonna look at this parent function and see how the changes are made. So we're gonna go to Desmos, click Graphing Calculator, and we're gonna graph this, okay? And we're gonna sketch it to the right, identify the vertex, so on and so forth. All right, so first we gotta get to Desmos.com. That is this right here. And we need to type in j of x equals x minus 4 squared. And that it is, okay? And we're gonna graph that thing, okay? Pretty straightforward. You're just gonna copy the graph from your computer page to your book here. All right, so looking at keywords, the vertex, we should probably just graph that thing, right? It's right here, right? It's at 4, 0. So graph it, 4, 0. That's where the vertex is. Another thing, the axis of symmetry, okay? So I just put 4, 0 for the vertex. Axis of symmetry is x equals 4, okay? That's gonna be the vertical line going right through the vertex, right? It's always the same. I've told you this before. This number 4 is the same as that number 4. They're the same thing every single time, guaranteed. Okay. And there's another point that we can easily get from our graph here. Got to zoom out a little bit. We can find the y-intercept right there, 0, 16. So 0, 16. Right there. So that's half of it, right? And then remember, we use the idea of the axis of symmetry. See how it's 4 boxes from here to here, right? So we go 4 boxes the other way. That's where the other point is. There we go. So we got our parabola graphed. We have some of that information. The domain, all real numbers. The range, remember, we should at least think of a horizontal line right here and realize, oh, it only exists above this line, right? So its y is greater than or equal to, well, the y value is 0. And again, I've told you this before as well, okay? This 0, whatever number is right there, it's always going to be that number from the vertex. The vertex is very important, it tells us lots of stuff. Okay, so, let's think big picture about this. Okay, this particular graph, see how it said x squared minus 4, sorry, x minus 4 squared? And it went, as you can see, to the right 4. That's a connection right there. When it says minus 4, it means right 4. Okay? So for number 2, let's think about this one. Okay? Think about this function x plus 3 squared. All right. Without graphing, can you predict the vertex and axis of symmetry? All right, well, without graphing definitely means using the graphing calculator, okay? You have to at least think about this, okay? Here's the parent function, right? That's just the x squared f of x equals x squared parent function. If it's a plus 3, a plus is the opposite of a minus, right? If it's a plus 3, what's that going to be? It's going to be left 3 from 0, 0. Okay, 0, 0 is the vertex of the parent function. We've seen that many times. So it's left 3. So that would be at this point here, which would be negative 3, 0. So that's our prediction for the vertex. By the way, we're correct, okay? Hopefully you could have predicted that yourself. And the axis of symmetry follows in line. X equals negative 3. It's always that same x value. The domain is always going to be the same. All real numbers. And the range, well, it will be the same as this because it didn't move up or down. It only moved left or right, okay? So the range is y is greater than or equal to 0. And if we graph this, we'll see that same function. It will look like, well, this on Desmos. Okay, so let's go back to Desmos and change this instead of a plus 4 or minus 4, it's a plus 3, and there we go. You can see it's at negative 3, 0. Okay, and then how about this? And so this function, fx equals x minus 4 squared plus 3. We just talked about above here, okay, in this problem. What does x minus 4 squared do? It moves it to the right 4, okay? So let's write that down, right 4. And just, was it just yesterday? I can't remember exactly. This plus 3, we know that moves it up 3. So in terms of x values, right 4 means plus 4, right? The positive 4 x value. And up 3 means a positive 3 y value. So the vertex is at 4, 3. How do you know? I just explained it, okay? Use Desmos to see if you're correct. We're correct, but we're going to type it in anyway. You should too. Okay, so put this minus 4 back here, and at the end, put a plus 3. And there we go. 4, 3. Right 4, up 3. All right, next page. All right, some quick notes here. All right, it's a little summary kind of thing. All right. Let's put a coordinate plane in the middle, okay? Leaving a little bit of space on the left and the right. Okay, I'm gonna put my parent function here in the middle, so you do the same. Okay, label that as x squared, okay? On the left, we're gonna have a blue function, okay? And on the right, we're gonna have a green function. Oh. All right, so have the space out like that. Still a little bit of space on your left and on your right, okay? Oh, why is it blue? Come on. There we go. Okay, so as you can see, these are just on a coordinate plane. Yay. All right, so the blue one, that moved to the left, right? Okay. We will call that g of x, okay? But you know it's the blue one. That is x when moved to the left, right? That means a plus h. H is like the generic letter we use for that spot and squared, okay? So first just get that written down. And then on the right-hand side, we'll call this one f of x. Okay, f of x equals x minus h. Okay, that moves to the right. Okay, so that's what that green one is, right? However many h's. Okay, so now we're going to do on the left the vertex. Okay, the vertex. Okay, what that is whatever the opposite of h is. So if it says +3, you're going to put a -3 in that spot. 0. Okay, that's the vertex. Okay, it's the opposite, as you can see from those h's. And here, the vertex is going to be at h. So like whatever, if it says -5, well, it's going to be a 5. And then 0. Okay, that's the vertex right there. And last thing we'll do here is the axis of symmetry. Okay, to abbreviate A of sim, okay, feel free to abbreviate that if you want. It's going to be x equals -h. Okay, it's always the same as that vertex x value. And then over here, A of sim, axis of symmetry, that is x equals h. Okay, hopefully that will help you with your homework right here. So you got homework right now, okay? Plus, you got something on Schoology to do. So do that as well, okay? So the rest of this page, homework. But your notes aren't done, okay? We're gonna go through these review things here, okay? And quite honestly, you should probably pause the video and then do it all, and then press play, and then see how you did, okay? That's what you should do. So after you do that, 10. Here's ways you're getting these. 0, -6, -8, -6, 0, and 10. Okay, and then when you graph those points, they're going to be here, here, here. Got to pay attention to your scale of your graph, by the way. Don't just think every box is always 1 for the rest of your life. It's not. Okay, so you're getting all these things. Hopefully you have these correct. It'd be great if you did. And you make your curve and put arrows on the end. You should have that. That should be the first one. Okay. Second one, find the other x-intercept. Okay, the other x-intercept is right here. It's obviously not labeled, and there's no grid to help us, right? Well, again, we went over this before. Okay, this is the axis of symmetry, right? It goes through at 1. We know that because of the x value right there. Okay, we can see that these are 2 apart, right? It's from -1 to 1 is 2 apart. That means these have to be 2 apart as well. So it's this 1 plus that 2. This is going to be at the x value of 3, 0. That's the other x-intercept. 3. Given the graph below and the reflected point to the y-intercept, what's the coordinate of the y-intercept? Okay, so it's the same basic thing, but we have to find this point right here. Okay, same exact thing. Right there, that's our axis of symmetry. How far away is this point horizontally from that point? Well, look at the x's. From -4 to -2, that's a distance of 2, right? That means from here to here is a distance of 2. Awesome. Does that help us? Well, it gets us the x value, right? Gets us 0 something, but we already knew that for the y-intercept. Oh man, did we just waste our time? No, we learned a little bit. We remind ourselves that, hey, y-intercept, okay? That always has an x value of 0. We need to find the y value. Wait a minute, isn't that the same level as that? Yep, it is. That's the y-intercept right there. 0, -2. Awesome stuff. Okay, what's next? Oh, and here we go with this. Given the below graph, find the coordinates of the other x-intercept. We have done this, right? Okay, we're trying to find this point. Okay, this one is 3 away. How do we know? This is at 1, we're told right here. And this is at the x value of -2. That distance is 3. That means this distance has to be 3. So you have this 1 that's in this space, plus this 3 right here is 4. So it's the x value of 4 and then 0 is the y value, of course. That's it right there. Number 5, match each graph with its equation. Well, let's look at the graphs. They're all parabolas. Okay, they're all facing up. Their vertexes are at different spots, right? So that's where we're going to have to look. You're going to figure out which equation goes with which. Well, this one here, this here means down 3, right? Well, which vertex was the same as the parent function? Remember, the parent function is this, okay? But it's just down 3. That's D. That's this one right here, D. Okay, next one. This one here means up 3. So which one is the parent function but up 3? This one here. C is that answer. Next one. This one here, it means right 3. Okay, so which one moved to the right 3? This one here, A. And lastly, this one here then, left 3. And there's only one more choice, but you can see it does move left 3, right? So that'd be choice B. All right, and number 6. The dashed graph below demonstrates the parent function f of x. Okay, I'm going to label that, by the way, f of x, okay, just so we don't get confused. In different colors, I'm going to use different colors, obviously you won't, but we're going to label them anyway. Different colors, graph each of the following on the same coordinate graph. We're actually going to change these because it gets too crowded, okay? So you got x squared here, plus we're going to change this to 7. Okay, so change that to x squared plus 7. All right, it's going to make it a lot easier for us. And here, we're going to change this one entirely, just x minus 5 squared minus 3. Okay, let's change those, otherwise it gets too crowded. That's the only reason why we're changing them, just so you know. Okay, so I'm going back to A. Okay, the h of x equals x squared plus 7. Okay, well, the plus 7 means up 7. Like, that's what's happening. So go up 7. That's where the vertex is. Now draw on the parabola. That's h of x. Done. Then we're going to do B. Okay, x plus 3 squared. That means the plus 3 right there means left 3. So go left 3. It's right there. And now draw on your parabola. And that'd be j of x. And lastly, this k of x, this new k of x, of course, right? This minus 5 means right 5. And the minus 3 means down 3. So right 5, down 3, right there. And then we draw our parabola. And you should label it, like I said, you probably don't have different colors, and that's fine. K of x. All right, that's that. I'm going to add this is not on your packet, of course, but I just want to go over all the things we've talked about so far. Okay, the generic, like encompassing everything form of a parabola, this is called vertex form, that doesn't matter to you right now, but f of x equals a times x minus h squared plus k. Okay, so I've talked about these letters. I've used h and k before. Okay, k, okay, that is a vertical translation. For instance, if it says plus 3, what that means is up 3. Minus 3 means down 3. Okay, very straightforward there. We learned that, I think, a couple days ago. This h we talked about, okay, we just got done talking about. This is a horizontal translation. Remember, translation just means moving. You're moving it, that's all. But here you can think of it as opposite. If it says plus 3, what it really means is left 3. If it says minus 3, it really means right 3. Okay? And the thing we haven't gone over yet is A. Okay? And we will do that, I think, tomorrow. I think when I get back tomorrow. And it has 2 parts. Okay? So I'll just introduce 2 parts. Okay? If it's positive, then it opens up. Okay? If it's negative, then it opens down. Opens up and opens down is different than a vertical translation of moving up and down, okay? So that's one thing it does, positive or negative. And the other thing, running out of space here, is if it's if A is between 0 and 1, that's what, 0 less than A less than 1, that means A is between 0 and 1. Then when this happens, okay, it's called a vertical compression. Vertical compression. And when A is greater than 1, so like 2, 3, 5, 1,000, okay, then that is called a vertical stretch. We haven't talked about anything with the A yet. We'll do that tomorrow. The H and the K, we have talked about that a bunch. All right, that's it. Have a great day.